So in this question, we have two sets of samples, one from the bottom of this lake, so 10 samples from here, and then 10 samples from here. The question is, how do these standard deviation compare for these two sets of samples? Was it greater for the bottom samples than that? So we have to compare them. I'll start with statement one. The least of the measurements, so the least value, exceeded the greatest for the surface sample. So that just tells me if these numbers are, for example, 1, 3, 3, 5, let's say 11, then here it's going to be 15, 19, 23, 23, so on and so forth. But that doesn't tell me anything about how the numbers deviate from the average, because standard deviation would be a measure of that, how far apart they are from the average. So 1 alone is insufficient. 2 says the range of the measurements from the bottom samples was greater. So these are spread far apart. So let's say the greatest is 100. And this surface sample is maybe, let's say, the least, the greatest is, let's say, 13. So that it's also lower than that value, because that, of course, that condition is for statement 1, but we're just comparing 2. The range is clearly greater for the bottom samples, but again, we don't know how the numbers are clustered. They could be clustered very close together here, and so the standard deviations can change. If you combine 1 and 2, we still don't know, because sure, we can satisfy that the least measurement here exceeds the greatest here, and also that the range are different, but the range only tells you about the extreme values. It doesn't tell you if the rest of the numbers are clustered close to the average or not. If they're all clustered close to the average, ignoring the least and the greatest, then the standard deviation would be lower. So it can go either way. So even combined, it's insufficient. The answer is E.